All right, excuse me. This is Geometry B, Unit 7, Lesson 3. We're continuing on 2D and 3D shapes. We're continuing our work on circles. You recall the formula for the equation of a circle was, let me write it out here, x minus h, hello, it would help if I have my pen, x minus h squared plus y minus k squared equals r squared. Okay, and on the left side I've got the equation for a circle centered at 4, -2 with a radius of 3. Okay, but I want to show you that this can be written another way. We can rearrange things so that it turns out a little different here. Okay, we can square things out. Let me go ahead and write out the steps. I could use the perfect square pattern, but which would be faster. But let me do it this way. X minus 4, x minus 4. Distribute, distribute. X squared minus 4x minus 4x plus 16. Combine the two middle terms. X squared minus 8x plus 16. Let's do the same with the y. Y plus 2 times y plus 2. Okay, distribute is y squared, so plus y squared, plus 2y plus 2y, distribute again, and plus 4. Okay, combine the two middle terms. 2y and 2y is 4y, so we get plus y squared plus 4y plus 4 equals 3 squared. 3 squared is 9. Okay, and now I want to draw your attention to something here, because this is a pattern we're going to use to our benefit here, and that is this. -8 came from -4 plus -4, right? And 16 came from 4 times 4, -4 times -4. So with the same number that adds to make the x term multiplies by itself to make the constant term. Same here. 4 is 2 plus 2, but 4 is also 2 times 2. The same number that adds to make the y coefficient multiplies to make the constant. We're going to use that here. But let me finish simplifying this here a little bit. Okay. So let's combine, rearrange things here a little bit. We have x squared, I'm going to cross these out as I go, plus y squared minus 8x plus 4y plus 16 plus 4 plus 20 equals 9. And now I'm going to subtract 9 from both sides, and we get x squared plus y squared minus 8x plus 4y plus 20, plus 11 equals 0. This is the equation of a circle again. Notice the original equation is in one form, and this equation is in another. Let me verify that that actually works in Desmos. Okay, I'm going to verify that that actually works, that those are the exact same equations. So I'm going to write x minus 4, quantity squared, plus y plus 2, quantity squared, equals 3 squared. And there it is. There's our circle centered at 4, -2. Right? I can even type 4, -2 here. And you can see that's the center, and it has a radius of 3. Okay, but let's try the other form. X squared plus y squared minus 8x plus 4y plus 11 equals 0. And all that happens is it turns blue. That tells me the circles are exactly the same. So these two forms create the same thing. Now, the problem comes in the fact that we're not always given the equation in this form, in the top form, but we're often given it in what we call general or standard form. And we need to be able to convert it from this to that. And that's a process known as completing the square. We've learned to complete the square before. Complete the square. So we're going to use this completing the square process to rewrite. So let's go to our next example here. So here's another equation of a circle. Okay, so let me go through the steps. And you might want to take notes on the steps here. Step 1, group the x's and y's together. X squared, okay, cross it off as I go, plus 8x, x's together, okay, and group the y's together. So I'm going to leave a little bit of space, plus y squared. So I'm going to leave a little bit of room for something in here that we're going to come back to. Plus y squared minus 10y. And then the plus 32. I'm going to subtract 32 from both sides and rewrite that over on the other side, equals negative 32. Okay? So all I've done is rearrange a little bit. I grouped the x squared with the 8x, left a little space for something. I grouped the y squared minus 10y and left a little room for something. And I moved the constant term to the other side, changing its sign, because the opposite of plus 32 is minus 32. Okay, now here comes the completing the square part. You remember how I talked about a perfect square is one in which the number adds to make the x term and multiplies to make the constant term. So what number adds to itself to make 8? The answer is 4. 4 plus 4 is 8. So think 4 times 4 is 16. That's what I'm going to add here in this space. Now we've got to obey the rules of solving equations, and that means I can't go willy-nilly adding things to one side and not the other. I've got to keep balance. So I'm going to add 16 not just to this side but also to this side of the equation. Okay? Now again, the same thing for the 10y, negative 10y. What adds to itself to make negative 10? Negative 5 plus negative 5 is negative 10. Now what multiplies by itself? Negative 5 times negative 5 is positive 25. So I'm going to add 25. That way the same number that adds to itself to make 10y multiplies to make 25. I add, now can you keep it balanced? I add 25 to the left, I must add 25 to the right as well. Okay, that's the complicated step. Now we can write the perfect square. This is simply x plus 4. So what goes in here is the number that was added and multiplied, 4 squared. X plus 4 squared, got the wrong color here. X plus 4 squared. Okay, and this is y minus 5. So plus y minus 5 squared. We're almost there. Equals negative 32 plus 16 plus 25. Well, 16 and 25 is 30, 41. 41 minus 32 is 9. Okay? And one more thing I'd like to do, 9 is a square, so I'd like to write it as a square. X plus 4 squared plus y minus 5 squared equals 3 squared. And this is a circle with a center at negative 4, 5, negative 4, positive 5. Remember the signs change. And a radius of 3. Radius of 3. Okay? Let's go ahead and verify in Desmos that that is the case. Okay? So I'm going to enter the original equation, x squared plus y squared plus 8x minus 10y plus 32 equals 0. There it is, centered at -4, positive 5, and a radius of 3. And it matches. It does have a radius of 3 units. You can count the squares. Okay? All right, one more, because this is so new. Right? You've done completing the square, but not two completing the squares in one problem. All right, so let's again, one more time, remind you of the steps. We group the x's together. X squared minus 4x. Group the x's together. Leave a little space. Group the y's together. Y squared plus 16y. Leave a little space. Equals, subtract 19 from both sides. We get -19 on the right side. Okay? Then break up the 4 in halves. What adds to itself to make -4? And the answer is -2 plus -2 adds to itself to make -4. So multiply that, -2 times -2 to make +4. If I add 4 to the left, I add 4 to the right. Now, what adds to itself to make 16, or what is half of 16? Well, 8 plus 8 makes 16. So 8 times 8 is 64. So I'm going to add 64 to both sides. Add 64 to both sides. Okay, that's the complicated step. Now write this as a perfect square. X minus 2 squared plus, oops, color again. There we go. Okay. So x minus 2 squared plus y plus 8 squared equals, and what all this works out to, 64 and 4 is 68. I think 68 minus 20 is 48, but give back 1, 49. 49. And one more step. X minus 2 squared plus y plus 8 squared equals 7 squared. And so this is a circle centered at 2, -8, with a radius of 7. Let's check it in Desmos. X squared plus y squared minus 4x plus 16y plus 19 equals 0. There's our circle, centered at 2, -8. There it is. And it appears to be right. And it has a radius of 1, 2, 3, 4, 5, 6, 7. Very good. So it matches. And that's it. That's the process of completing the square to change the form of the circle.